All right, so well, we just heard a little bit about who I am. Now, the real question I have for you guys is, who the hell are you? So, how many of you consider yourselves to be developers? Good chunk of the audience. How many of you work in video today? Hardly anyone at all, a small handful. How many of you have plans to be working in video in the near future? Small handful again. How many of you have worked with MediaSource Extensions at all? 1.5 hands. Okay, cool, perfect. I guess you guys are allowed to stay. So here's what we'll be talking about today. We'll talk about video and the internet and where we are and where we want to be. We'll talk about streaming via HTTP. We'll talk about what are the options for streaming. We're going to talk a little bit about Dash, which is specifically dynamic adaptive streaming over HTTP. It's an open standard in this world, and we'll talk about why that's interesting, a little bit about the Dash 264 specification, and then we'll dig into some code and see how do we make it all work in a browser, and what does it all mean. And of course, there's time for questions at the end, and if you have questions, don't wait for the end. Just, raise your hand, shout at me, whatever. I'm all good for interaction. Interactivity is good. So as you guys probably know, video on the internet today, we've got sort of 3 core options. We have progressive download, and it sort of starts with 2 core options. We can either do progressive download, and the idea of progressive download is the file comes down into the browser and plays a little bit at a time as it's going, but really there's one file that you're downloading, and it's merely playing back as it downloads. The other option is streaming the video, which means just little bits of the video are sent into the browser at a time. And we've got a lot of flexibility with streaming the video, because if we're only getting a little at a time, we've got the ability to do things like adaptive bitrate, where we can switch the quality that we're playing on the fly. We're not stuck with, well, I'm playing this one video, and this video is only at one quality. And within the streaming video side, there's really 2 different options. There are the real-time protocols. You might be familiar with RTMP was a flash standard. There's RTSP and RTP. In all 3 cases, they're a real-time protocol, which effectively opens a socket between the server and the client and just pushes data across the socket as needed. And there's a lot of nice things about real-time protocols, but the problem, the reason people aren't so thrilled with real-time protocols and they're moving away from them, is they're not terribly efficient, especially for large-scale events. We recently worked on the World Cup with ESPN, and we had something like 1.9 million simultaneous viewers. If we had to have an open socket from the server to every one of those 1.9 million people, it never would have worked. We would have had to have hundreds of thousands of separate servers to serve all the content, and it just wouldn't be a good idea. Okay, tens of thousands, maybe not hundreds of thousands, but you get the idea. It would require a ridiculous infrastructure. So the alternative in streaming today is HTTP streaming. And the idea of HTTP streaming is we have our content segmented into discrete files that can be served over any standard web server. And as you guys all know, Apache or IIS or even just a Node.js web server or whatever web server you like is built to handle a lot of traffic. It can simply respond to requests all day long, and it does very well. We can have far more connected clients with far less infrastructure. We, of course, also have a whole internet that's built around caching and optimizing HTTP traffic. So the more we can leverage the technology of the internet, the better off it's going to be. The easier it's going to be, the more cost-effective it's going to be. And so HTTP streaming, and again, the main protocols you'll hear on that, HDS is Adobe standard, HLS is Apple standard, smooth streaming is Microsoft standard. You might notice all 3 of the options I've mentioned are proprietary standards to one company or another. This will become relevant when we talk about Dash in a few minutes. So, part of the challenge that we have today, most folks agree that HTTP streaming is the most efficient. It's not to say it's the be-all and end-all solution. There's some things that the real-time protocols do much better, but in terms of network efficiency, HTTP, it's just the most efficient. Part of our challenge today is that we have different devices that support different protocols. And so we have a challenge. Are we going to try to support every possible protocol? Are we going to just pick and choose which devices we want to support? More often than not, content providers who have lots of video content, they want to hit everyone. And so we end up trying to support all sorts of different protocols at the same time. No one standard is currently ubiquitous. There's no one of the options will work everywhere. And we're getting a little bit closer to that. HLS is now supported by a lot of different devices. That mostly became somewhat of a de facto standard because the iPad was so popular. The problem, of course, is that the HLS support on different devices is, on virtually every device that's not an iPhone or iPad, is really weak. And there's reasons. Talk to me over a beer tonight. I'll be happy to explain to you why that is. We don't have time for that at the moment. But there's a lot of different options and a lot of different variability. And so the result is that we end up serving the content in several different ways, and we have a lot of storage costs, and we have a lot of transport costs, and a lot of different challenges. And so as we're talking about streaming or pushing video to a browser, we've got a couple different options. The only thing that's really ubiquitously supported across all of our HTML5 browsers today is progressive download. And progressive download has a lot of downsides to it. If you're doing simple short-form content, you're doing a 30-second clip of a sporting event or of a video, an advertisement or things like that, and that doesn't need content protection, progressive download works fine. But if what you're trying to do is anything more complicated than that, wanting adaptive bitrate is a pretty big reason not to have progressive download. Not wanting to have your full video sitting in some browser's cache is another pretty worthwhile reason that progressive download's not great. The other challenge we have, of course, is that different browsers support different codecs. Are you guys familiar with the term codecs? Anyone? So the idea of a codec is an encoder and a decoder. Basically, as we take a large video file, we want to compress it, and we want the browser to be able to decompress it, or wherever we're playing it back, it needs to be able to be decompressed. And different browsers traditionally had chosen different codecs they were going to support. And some of the codecs you'll see listed here, H.264 is one of the more popular codecs today, VP8 and VP9. Less popular, but they're an open standard, so in certain crowds they're very popular. And there's a lot of different options here. And it's actually gotten slightly easier on the codec front recently. A few months ago, Cisco has decided to pay for the licensing for H.264 for every browser manufacturer. So now there's no longer a monetary reason for browsers to not support it. It can now be ubiquitously supported for free, which is great. In terms of streaming content or HTTP streaming, Safari, but only on iOS and macOS, will natively support HLS. No other browsers will. And the thing that we'll be talking about more is MediaSource Extensions. MediaSource Extensions, and we'll go into more detail on this, is something that browsers are starting to support, and we're making really good progress on that. So what are these MediaSource Extensions? Well, ultimately what these are is these are a W3C specification that more or less gives us an API into the HTML5 video tag. So what this means, traditionally your HTML5 video tag, it has an attribute, you tell it what the URL of the file you want to play is, and it goes and downloads that and does progressive download. Safari on iOS and macOS took it a step further, and they said, rather than just giving us the URL of a file, you can give us the URL of a manifest, and it will figure out how to do everything else from there. What MediaSource Extensions does is it gives us the ability to write in JavaScript something that will download the files and just hand a little bit at a time over to the browser, to the video tag. And so we have now the ability to really build our own streaming application and have the control that we otherwise lack in our streaming applications. The great and terrible thing about the way Safari handles HLS is that we have no control. We simply give it a URL to the manifest file, and it does its work, and we have no way of saying, I think you should play a higher bit rate or a lower bit rate, or I want you to put more in the buffer or less in the buffer. We have no control. It's going to do what it's going to do, and that might work for your use cases in the business, and it might not. With the MediaSource extensions, we get a full API around these things, so we can write that application to behave in any way that suits our needs, which, as a developer, I like more control. From an ease of use, certainly it's much easier to say, here's a URL, just go deal with it. But as a developer, and I've got clients who are always asking me, like, well, I want it to do this or that instead, having that control allows me to meet the specific needs of my clients. And so really with these MediaSource extensions, by being able to download individual segments, and these segments can be anywhere from half a second to 10 seconds of content per segment, I can download them and I can hand them over to the video tag to play back. And before I download the next one, I can make a decision. Do I want to keep the same bit rate? Do I want a higher quality? Do I want a lower quality? And so I'm really doing full streaming directly into the browser this way. Now, there's a caveat. It's not universally supported yet. The reality of MediaSource extensions today is that it's fully supported in Chrome and has been for about a year. I think Chrome version 23 was the first one that supported MediaSource extensions. It's fully supported in IE 11, but only if you're running Windows 8.1. If you're running Windows 7, it's not supported in IE 11. Firefox has put it on their roadmap. It's part of, I think, Firefox v33, which is slated for an October 14th release. It's in a beta. It's in one of the betas in Safari also. I forget what the code name of that beta is, but it's supposed to ship before the end of the year as well. What this means, though, is that we will very soon be in a situation where about 75% of all the browsers will have this built in. It'll be the reality. It'll be a really effective way. It'll have a higher market share than Silverlight had in its heyday, which is pretty impressive. Remember, Silverlight had high enough market share that companies like Netflix decided it was a good enough choice for them. The reality now, Netflix is streaming almost half of their video via MediaSource extensions instead. And the current state of the specification, it's currently in editor's draft as of this month was the last update. And I'll share the URLs for where to find the spec if you're interested. So now that we have this ability to stream content in, we need to figure out what kind of content, what will the browser accept, and how do I do it? MPEG-DASH is another HTTP streaming format that has two key differences from the other three I mentioned before. The first, and for many more important of the differences, it's not owned by one company. It's not Apple's or Adobe's or Microsoft's standard. It's an open standard. In fact, if you go and read the specification about it, you'll see it was written by the folks at Apple and Adobe and Microsoft and Google. So it's an open standard it's getting good traction. And the other most interesting thing about it is it's much newer than all of the other specifications and was largely written by the people who have learned lessons. What were our specifications missing? And so Dash takes in a lot of use cases that weren't considered when smooth streaming and HDS and HLS were first created. And it's built much more flexibly. One simple example of that is Dash not only allows you to, actually encourages you to demux, separate your video content from your audio content. Why is this important? If you think about a broadcast that has multiple languages, the traditional approach when the audio and video are mixed together is you have to duplicate all of the content, both audio and video, to create a second language version of it. So if you have a 4 gigabyte file that's your audio and video for English, you'll have another 4 gigabyte file that's your audio and video for Spanish or French or German or whatever language you're doing it in, as opposed to a 3.5 gigabyte file of just the video, and then a couple hundred megs of one audio language or another audio language. Your storage costs can be tremendously dropped. And it also allows for much smoother switching on the fly from one language to the next if you need that feature. That's just one of the many features where Dash has realized the problems from the other specs and taken it a step further. And the goal of Dash, the final bullet point here, is to try to give us one unified standard that will work everywhere. And we're not beholden to any one company to use it. So, while today Smooth and HDS and HLS are all built specifically around H.264 as a codec, Dash is codec agnostic, meaning it doesn't care. Dash is mostly a way of describing where to find the content and describing what the format of the content is going to be. But it doesn't care whether that content is H.264 or VP8 or VP9 or H.265. In the video world today, I just came back from IBC, the International Broadcasting Convention, and the whole industry is waiting patiently for H.265, the next generation of the specification. And when that comes out, all of the other formats are going to have to retool to be able to accept it. Dash doesn't care. Dash is built to deal with it today, which is very nice. Again, I can talk more about H.264. Find me over a beer tonight. We can talk for hours about codecs if you are interested. You don't have to. It's okay. The other interesting thing that with Dash is its manifest, it allows us to describe the same content in different ways. So if you're trying to hit several different browsers, you can describe your content. It's like, here's the WebM version of my content. Here's the MP4 version of my content. Here's the H.265 version, or whatever else you might want to describe. One manifest allows you to describe it individually. So, as I mentioned earlier, H.264 today, it is the dominant codec on the web. And so a group got together, the Dash Industry Forum, and this is a group of about, I think, 80 different companies now. And what they really wanted more than anything else was to make sure we could build content that would be interoperable. We wanted to have Dash. Dash as a specification does an awful lot, but it's really non-specific. And as a developer, it drives me nuts to read a specification that has lots of mights and mays and very few musts and shalls. Dash, unfortunately, as a specification, is trying to be open to be all things to all people, which leads to it's really easy to create content that's not interoperable. So the Dash Industry Forum got together and created a narrowed down version of the specification to say, if we can get together as a group, and these 80 companies, and they're encoding companies, and they're CDNs, and they're player companies, and DRM companies, if we can agree that we'll build our Dash content this way, we can all know it's going to interoperate with each other, which is really nice. And so that's the idea of the Dash 264 specification, and that's not actually the right name. The full name of it is the Dash AVC / H264 specification, but that's way too much of a mouthful, so I just call it Dash 264. It gives us this clear, narrowed down implementation that meets the vast majority of use cases needed by 95% of its members. So that's the idea there. As I mentioned, the Dash Industry Forum, they're a group of a whole bunch of people to try to drive Dash adoption. And actually, I didn't update this slide. Last time I wrote this slide, we were only at 65 members. We're now up over 80 members. And if you're interested, dashif.org is our website there. All right, so we have Dash, we have MediaSource Extensions. How do we make it work? How do we pull this all together into something that will work today? And so at Digital Primates, we're front-end consultants. We write lots of applications. And so we've written a number of different Dash players. We started off with Flash. We've done them for Android. And now HTML5 and JavaScript are what we're writing our players for as well. And I'm going to talk in detail about the HTML5 JavaScript one, largely because it's an open source that I can share the code and anyone can go grab it and play with it and do whatever they want with it. The Flash and Android ones are owned by various clients that hired us to write them over the years, so I can't share that code with you. But the JavaScript one, free, open source, BSD license, go do whatever you want with it. And you can find that code on GitHub. So in order to play a Dash stream, and really taking a step back, in order to work with any content in MediaSource Extensions, you're going to have some clear steps, right? First, you have to figure out where's the content. You're going to have to download that content. You'll have to make choices about what bit rates you want to be at. You'll initialize the video tag. And And then you'll start handing content over the video tag. All the while, you're going to be making decisions about, is this the right bit rate? Should I go up? Should I go down? And so specifically in Dash, we'll start by downloading the manifest. Now, a manifest file, it's nothing but an XML file. I've got a sample one here. So here's a manifest file. And really what it describes to us is the content. What is the content? Where do I find the content? What bit rates are available? What codecs are being used by those bit rates? So really, it's all about what's available, how do I get it, how do I use it? So we'll download the manifest and parse it. One of the things that we're doing in dash.js, again, I mentioned we have to make choices. What bit rate should I be playing? Every time we download something, we measure how long did it take to download that file? How big is that file? What estimates can I make about what bit rate, about what bandwidth is available to me? And we've got that and a series of other rules that we use to try to make our adaptive logic, our adaptive bitrate logic, work. So as we're downloading the manifest, we're figuring out, okay, this was a 20 kilobyte file. It took me 15 milliseconds to download. Therefore, I'm guessing I have so much bandwidth. It's not the greatest metric in the world, but it's the first metric we have. So we'll determine, off of that, an initial bit rate to start on. And then, based on the manifest, we'll figure out how do I start requesting the segments for that bit rate. I'll download the initialization fragment. And really what the initialization fragment is it's just the header information from the MP4 files that effectively tell the video tag, hey, you're going to play some content, and here's what it's going to look like. Here's the codec, here's the bit rate. It allows it to know how to play the content. So once we initialize it, we'll start downloading segments and handing the segments over to the MediaSource extension. All the while, as we're downloading and playing back, we're watching for events from the video tag so we can know, hey, look, it's dropping frames, or hey, look, it's taking too long to download this content. I want to switch to a different bit rate, so as it makes the next request, it can know, okay, I'm going to request higher or lower. So Dash has a couple different ways in its manifest of describing the content to you. But to start, we've got a couple different file types. First, we have our manifest file. As I mentioned, this is just the XML file that describes the content. It tends to be a .mpd extension. We have our initialization segments, which really are just files that contain part of the MP4 box structure. And then we have the individual segment files, which, as I mentioned before, are a discrete chunk of content. And depending on how your encoder is set up, they could be anywhere from, at the extreme small side, half a second for a segment. At a more average size, about 4 seconds a segment. I've seen 60-second segments. But usually 4 seconds to 10 seconds is kind of the sweet spot where it makes sense. And so we'll have 0 or more segments for video and 0 or more segments for audio. Why 0? Because we might have an audio-only broadcast, or we might have a video broadcast without audio. Our Dash manifest, the XML file that describes to us how to find this content. And really what we'll find is there's a root node that just says this is an MPD file and here's some basic information about it. Inside the root node, we'll have 1 or more periods, and the periods describe discrete sections of content. The most common use case for periods in this, by the way, is advertising. We're going to say we're going to have 15 minutes of content, then here's a 30-second ad break, then here's another 15 minutes. It's a way of separating out the core content from other ancillary content. So each period will have 1 or more adaptation set for video and for audio. The adaptation set will all contain what's deemed functionally equivalent content. What does that mean, functionally equivalent? As you guys probably know in the video world, there's 2 different main formats of the aspect ratio of the content, right? Some content is in 4:3, which is a little bit more square, less rectangular. And then there's the more widescreen, the 16:9. It would be a really jarring experience for the end user if, as it was switching bit rates, it jumped from 4:3 to 16:9. It would be unpleasant. It would not make anyone's life easier, or it wouldn't be a good user experience. So if we're going to have both 4:3 and 16:9 content of the same asset, what we'll do is we'll have them in different adaptation sets, so it won't switch back and forth between them. The idea is that within the same adaptation set, it's free to switch to whatever bit rate within that adaptation set to keep a same experience for the end user. Does that make sense? Same thing on the audio side. It can be very jarring if you're watching in 7-channel surround sound to suddenly drop down to mono. Right? It suddenly feels like there's a hole in the audio, or it's from all around you, something's in one place. So normally, the different audio content like that in that size would be described with different adaptation sets. Within each adaptation set, you'll then find the various representations, which ultimately are the bit rates that describe to you the individual content. As we're building these manifests, different encoders will do it differently. And the initial Dash specification has something like 8 different ways of describing it. The Dash 264 spec reduces it to these 3. We can have a segment base, which really is just saying this, on the server there's one file, and we're going to use byte range requests to send down individual pieces of that file. The segment list, which is simply a listing, here's all the segments, and so you can use that to figure out which ones you need, or the segment template, which is by far the most popular and the easiest to use. It's wildcards. So basically you're saying you're just going to replace the segment number, or you're going to replace a time. And we'll take a look at each of these. Right, so a segment list very simply looks like this. Here's a series of URLs, and you play one, then the next, then the next. And since we know what the duration of each segment is, it's very easy to seek. We know if, in this case here, they're each 10 seconds long, so if I want to jump 3 minutes in, I jump down to the 30th segment. If we have a segment template where every segment is the exact same duration, this here is all you need. And you'll see in blue the wildcards, right? So there's $number, $sign in there. That's telling us, just in this case here, it's segment 1, then segment 2, then segment 3, then segment 4. And so that wildcard is simply replaced each time through. Now, oftentimes, especially as we deal with variable content, if you're dealing with live sports, for instance, you don't always know when an ad break is going to happen or when something has to change. So you might have variable durations of each segment. And so for that, we have a segment template with an embedded segment timeline. And so what this does to say is generally, here's what the pattern is going to be. You're going to specify the bandwidth and the time. And then for each of the individual segments, here's the duration of each one. And if I'm going to stay at the same duration, you notice the bottom one has an R attribute to it. That tells you I'm going to repeat at this duration for whatever number of times. So it's not uncommon to find something like this where the timeline, where the first thing inside the timeline simply says, I'm going to repeat at this one for 153 times, and then the next one is at a different duration, just based on, the change happened on the fly. Somebody clicked the big red button that said go to ad, and they weren't the full 10 seconds through the segment. They were only 2 seconds in. Rather than having 8 seconds of dead air before it cuts over to the commercial, you can instead say, okay, this segment's only 2 seconds long, and then we switch on to whatever's next. So the dash.js player, as I mentioned, free open source project, GitHub, BSD license. It's a project that we initially built as the reference player for the Dash Industry Forum, and the idea really was to test interoperability. It's actually grown and it has more of a life of its own now. A lot of other companies have taken dash.js and used it as the basis for their own video players. This past spring, the BBC did a series of concerts on the web in Dash with dash.js, which was very cool. Now, the problem for me as an open source developer, and I'm sure anyone else who's an open source developer in the room knows this, I have no real way of knowing who's using this. I know these guys because they told me. But there's a lot of different forks. Every once in a while, I'll just start searching the web for various class names that I know that are in there. And of course, if they're using the minified version of the code, it's not going to work. So I don't know who else is using it, but I know there's a lot of folks out there who are currently using it. So we already talked earlier about how the Dash stream works, right? So dash.js has a couple core libraries. There's actually only one library now. Through the various refactors, we've got it down to only one external library that's required. And we've started with 5 or 6, and with each new release, we've narrowed it down to try to get the footprint of the player a little bit smaller. Currently, the only thing we have is Dijon that we're using for a dependency injection framework. And the whole idea behind how many of you guys are familiar with dependency injection? Not as many as I would have thought. Okay, that's cool. The idea of dependency injection is at runtime, it's able to effectively bring in the classes and have figured out what dependencies it has, so it becomes much easier as a developer to rip out things that you don't want. So as you're trying to slim it down, you can only include the pieces you want. If you want to replace, if you don't like the way that our code is handling buffering, you can rip out our buffer class and very simply say, no, I want you to use this other one instead. And that's what the dependency injection is all about. It just gives us a lot more flexibility and allows folks to use it to be whatever it is they want from the application. We use Jasmine for unit tests, and the website that hosts the player currently uses a bunch of other frameworks. But if you're going to use this on your own, the only thing you need to care about is Dijon. The rest of it is optional. If you're going to be writing code for us, we want you to write unit tests, though. So the class structure here is divided into 2 core pieces. There's the streaming package, which has all of the basic MediaSource extension elements to it. And so this is what knows how to hand content over to the video tag, how do I listen for events, anything that's not at all specific to any other technology other than MediaSource extensions. We have a second package, which is the Dash package, which has any specific code related to Dash. And the reason we've done this is we sort of knew from the beginning that while Dash is really nice for working with MediaSource extensions, there's no reason that we couldn't take the same thing and have it work with HDS or smooth streaming or HLS. I'm actively involved with one of my clients in writing a series of HLS elements that will just plug in the same way. And HLS is a little bit more complicated because it's describing the segments differently than HDS or smooth would or Dash would. But any of these things are possible. So anything Dash specific's in a Dash package, everything else is in the streaming package. And so our streaming package, the core class, the main thing you'll want to interact with if you're going to use this, it's our media player class. Right? And this is the one that's actually responsible for exposing all the top-level functionality to a developer. And ultimately, we're just going to we'll create our instance, and we'll pass it a reference to the HTML5 video tag and to the URL for our manifest. And then behind the scenes from there, all the magic happens. So there's a context, as I mentioned, the dependency injection. The context class is where you set up your dependencies for your dependency injection. Our stream class is responsible for creating the buffers and listening for events and exposing it back to the media player. One of the more interesting things, if you haven't done a lot of work in video, and specifically in live video, you might think video is video. And there's no real difference between video on demand and live video. And you'd be wrong. The reality is that live video is extremely complicated. And one of the more complex parts of it is understanding what does now mean. Right? You start the stream with a live video. You want to start at the extreme edge. You want to have the most recent segment start playing for you, right? When you start, you don't want to start 15 minutes ago. You turn it on and you want to see what's happening now. And calculating what that means is extremely complicated. And Dash has not made it simpler for us. So one of the things that we have inside Stream is all the calculations for determining what does now mean. What is the live edge? Again, feel free to pull me aside over a beer tonight. I can go into far more detail than you really want to hear. Some convenience classes for debugging. BufferController, it's where our buffering logic is. And this one gets overwritten quite a bit by different implementers based on what their particular needs are. Some folks would rather buffer a lot of content up front and have less worries later about having to switch. Other folks would rather buffer as little content as possible up front and slowly build that buffer over time. And so there's a lot of different approaches to how you want to handle buffering. Again, there's one simple class where it's contained, and it can be overridden, replaced, or extended as needed for the individual clients. Two of the core classes, one for loading manifests, one for loading fragments. I'll use the term fragments and segments somewhat interchangeably. There is a technical difference between the two, but as far as we're concerned here, they're basically the same thing. Our controller for all of our adaptive bitrate logics in our ABR controller, ABR adaptive bitrate. And then we have a series of rules that we use to compute, is this the right bitrate? Should I switch? And ultimately, we have an array of rules that we'll run through with some frequency. The most basic of the rules is the download ratio rule, which will very simply measure for us. We'll know how long each segment is. So this is 4 seconds worth of content. If it's taking me 10 seconds to download 4 seconds worth of content, this isn't going to work. I'm going to need to change this to something else, right? Or if I'm downloading it very quickly, and again, in the same place, we know how much content's in there, we know how big the file is, we know how long it took to download. So we're able to make some suggestions and guesses about what our bit rates are. Another core one, the insufficient buffer rule, where we're just figuring out, hey, I'm adding content into this buffer at a slower rate than content is playing back. My buffer is going to run dry if I don't do something quickly. So again, just some very basic rules. And as I say, there is, inside our ABR controller, there's an array of these rules. And it's relatively easy to create your own rules. So we started with a couple of very basic ones, but I know with each deployment, we've had a different set of rules that have gone out, and each of our clients has their own particular requirements for what they want and what they need, so those are all proprietary to the various clients that we've built them for. The first two that we built are the ones that are easily available back to anyone that wants to use them. The dash package is where any of our dash-specific logic goes, so there's a separate context where we include our dash-specific classes. And that includes things like how are we parsing, how are we, the index handlers, how do we figure out which segment is next? How do I figure out which segment to download? And so ultimately, our index handler has two core methods. It either has the method of getNextSegment, which will take a single argument of which bit rate should I get it for, or it has the other method of my display is not happy. That was strange. Or it has another method inside the index handler, getSegment for time, if I'm going to seek to a particular point in time. So that method takes two arguments, the time I'm seeking to and the bit rate I want to play back. So the index handler is purely responsible for figuring out which segment I want. Our dash parser actually takes the manifest, creates it into JSON, and then figures out what to do with all of the values. This is the index handler I talked about, has get segment request for time, get next segment, tells us the current time, where am I in our playback now, so on and so forth. Get the init request tells us how to get that initialization segment so we can prime the video to play. And ultimately, the flow to use this, and this seems a little bit more complex than it really is. We create a context. We create an instance of our media player, and we pass it the context. And then the dependency injection magic happens, and it figures out which other classes are going to get used within the media player. We'll then call startup on the media player, effectively initializing our media player. We're going to tell the media player, is this live content or not? And the main reason for this has more to do with the UI and with the basic behavior. Am I going to start this video from the beginning or from the end? Right? In live, when you start a live broadcast, you don't start from when the broadcast started 2 hours ago. You usually want to start from now. What's the most recent? So set is live just tells the player, am I live or am I VOD? And then we give it the URL. And lastly, we pass it a reference to you see we've got just the simple query selector to get a handle on our HTML video element and attach the view to the player. And really, that's if autoplay was set to true, it just works. And this is all you need to do to get started. Now, once that happens, there's all this other stuff that happens behind the scene. you don't need to worry about that if you just want to use the player. If you want to understand it and dig in and create more for it, this is all worthwhile, and the slides will be available to everyone. So I only have 5 minutes left, and I want to make sure I leave some time for questions here. So one more thing to understand is just within the buffer manager, there's the validate, which is called on with some frequency. It's called in a timer. And so it's able to basically go through and check our rules and see, do I need, am I in a good place with this bit rate? Do I need to go up? Do I need to go down? Should I be buffering more? Or should I be buffering less? If you want to learn more, the Dash Industry Forum, there are URLs here. You can always find the latest reference player off the second link here. The source code up here is on GitHub. If you want to understand MediaSource extensions or encrypted media extensions, here's the URL for the actual specifications. Sorry, quick side note, I didn't mention EME earlier. EME is the way that we can do content protection. We can do digital rights management within these same HTML elements. And it's supported in the same browsers. And of course, you can find me on Twitter, either at Jeff Tapper, which is me personally, or at Digital Primates. That's my company. Whew, questions? Over here in the green shirt.
So it's a JavaScript API,
So I'm just going to repeat it back for the camera, so I don't know if they can hear you. You don't have a microphone. The MediaSource extensions are effectively a JavaScript API to the HTML5 video tag, allowing us deeper control over video playback.
Does it allow interoperate with WebRTC?
Yes, there are, in fact, so it's a question about interoperability between WebRTC and MediaSource extensions. There's actually a number of different companies I've been talking to who've been using WebRTC along with MediaSource extensions to build out peer assist download, which is very cool. Question in the back. So it's a question about packaging the file to make it available, to make it segmented so it can be downloaded. And the short answer to that is maybe. Depends on the server it's coming out of. Some servers will allow for byte range requests, in which case there's just the one file for each bit rate sitting on the server, and you pass in HTTP headers with each request to say, I want bytes 1 through 299. So in that case, the server does more work. There are a number of different packagers that are available. There's one called MP4Box that is a free open source one as well that will do packaging for you. There's a number of commercially available packagers as well. But the same packaging or a similar type of packaging will need to happen for any of the HTTP streaming protocols, whether it's HLS, HDS, or smooth streaming, or Dash. Other questions? Nothing? Was it worthwhile? Useful? Yes? Okay. Well, thank you.